On the cold night of October 15, 1991, the sensors at the Fly's Eye Observatory in Utah didn't just register a signal, they screamed. The data that flooded the control room was so violent, so astronomically off the charts, that the researchers' first instinct was to assume the equipment was broken. It wasn't. They had just witnessed a ghost, a single subatomic particle, a proton, a speck of matter so small it has no meaningful width, had slammed into the Earth's upper atmosphere with the kinetic energy of a fast-pitch baseball traveling at 60 miles per hour. We're talking about 50 joules of pure energy packed into a sub-microscopic point. In the realm of particle physics, this isn't just an outlier, it is a violation of the rules. We named it the "oh my God" particle, and decades later it remains a scar on our understanding of the universe. To truly grasp the absurdity of this event, we have to strip away the human scale and look at the numbers. The Large Hadron Collider, the most sophisticated machine our species has ever built, smashes particles together to pry open the secrets of reality. We measure these collisions in electron volts. The LHC operates in the range of tera-electron volts, or trillions of electron volts. The "oh my God" particle hit us with 320 exa-electron volts. That is 320 quintillion electron volts. This single proton carried 40 million times more energy than the most powerful collision humanity has ever engineered. It was a bullet fired by a cosmic gun we cannot see, cannot locate, and cannot comprehend. The speed of this particle forces us to confront the absolute limits of relativity. It wasn't just moving fast, it was skimming the razor's edge of the universal speed limit. It was traveling at 99.9999999999999999999999999999999999999999999999999% of the speed of light. That is 23 nines after the decimal point. If you could stage a race between this proton and a beam of light from Earth to our nearest neighbor, Alpha Centauri, a distance of over 4 light-years, the light beam would win, but only by a fraction of the width of a human hair. At that velocity, the laws of time collapse. For the particle itself, the journey across millions of light-years would have felt instantaneous. It experienced the universe not as a vast expanse, but as a single, compressed moment of existence before it annihilated itself against our sky. But here lies the paradox that keeps astrophysicists awake at night. This particle should not have survived the trip. Space is not empty. It is filled with the relic radiation of the Big Bang, the cosmic microwave background. For a proton traveling near the speed of light, these low-energy photons appear as high-energy gamma rays due to the Doppler effect. When they collide, they should produce pions, draining the proton's energy. This is known as the Greisen-Zatsepin-Kuzmin limit, or the GZK cutoff. It acts as a cosmic horizon, a speed trap that strictly limits how far ultra-high-energy cosmic rays can travel, about 150 million light-years. Any source further away should be invisible to us at these energies, yet we see no sources within that horizon capable of launching such a missile. The "oh my God" particle didn't just break a record, it broke the theoretical ceiling of how the universe is supposed to work. Building on that spectral glitch in our standard model, the universe decided that one impossible event wasn't enough. For over 30 years, we hoped the "oh my God" particle was a statistical fluke, a freak accident of nature. But in 2023, the telescope array in Utah shuddered again. This time, it caught a new monster, the Amaterasu particle. Clocking in at 240 exa-electron volts, it is the second most energetic ray ever detected, confirming that the cosmos is indeed firing bullets at us from the dark. But Amaterasu brought a new, chilling layer to the mystery. When astronomers traced its trajectory backward through the sky to find the cannon that fired it, they didn't find a violently active galaxy or a supermassive black hole. They found absolutely nothing. The oh my god particle had loosely pointed toward the Perseus-Pisces supercluster, a region rich with potential, though insufficient, sources. Amaterasu, however, came from the direction of the local void. This is a desolate, spherical region of space bordering our Milky Way, spanning millions of light-years of emptiness. It is a cosmic desert. There are no churning magnetic maelstroms, no exploding stars, no active galactic nuclei capable of acting as the particle accelerator required to produce 240 EeV. The particles seem to emerge from the vacuum itself. If standard physics holds, there is simply nothing there powerful enough to launch it. This forces us into a corner with only two disturbing exits. The first possibility is that our map of the universe is fundamentally flawed regarding magnetic fields. Cosmic rays are charged particles, meaning they bend in magnetic fields. If the magnetic fields between galaxies are significantly stronger or more complex than our models suggest, these particles might have been twisted and turned so violently that their arrival direction points nowhere near their true origin. We could be staring at the local void while the culprit hides behind us. But to bend a particle with this much momentum, imagine trying to turn a speeding freight train with a gentle breeze. The required magnetic topology becomes almost as inexplicable as the particle itself. The second possibility is far more radical. It suggests that these particles are not being accelerated by something, but are being created from something we have yet to discover. We might be witnessing new physics in action. Some theories propose that these are the decay products of super-heavy dark matter, hypothetical particles lingering from the dawn of time that are finally breaking apart. Others suggest we are seeing defects in the texture of space-time itself, cosmic strings snapping and releasing bursts of unimaginable energy. If this is true, the local void isn't empty. It is a graveyard of primordial physics, quietly decaying and firing high-energy shrapnel across the cosmos. We are being bombarded by messages from the architecture of reality, and we barely know how to read the first letter. The universe is not just stranger than we imagine. It is more violent, more energetic, and more mysterious than our equations allow.